If you've ever watched a movie with fighter jets in it, chances are you've heard them talk about Mach numbers. Yet while pilots in these movies will routinely talk about planes traveling at Mach 2 or 3, what does that mean? What is Mach? Before we go to sonic speed, we need to understand Mach number, or you can simply say Mach. Mach is used as a unit of measurement in stating the speed of a moving object in relation to the speed of sound. For example, if an aircraft or missile is traveling at Mach 1, it is traveling at exactly the speed of sound. The speed of sound is 761 miles per hour, therefore, the object is moving at 761 miles per hour. For general categories define the speed of missile or flight: subsonic, transonic, supersonic and hypersonic. Each is relative to a Mach number. Subsonic missiles are slower and the speed of sound. Subsonic missiles are slow and easier to intercept, but they still play a huge role in modern battlefields. Not only are they substantially cheaper to produce as the technological challenges have already been overcome and mastered, but subsonic missiles provide an additional layer of strategic value due to its low speed and small size. Once a subsonic missile has been launched, it can loiter in proximity to its intended target as a result of its fuel efficiency. This, combined with its comparatively low speed, gives senior military decision-makers ample time to decide if a strike should be continued or abandoned. A transonic missile is typically between Mach 0.8 and 1.2. It is called transonic because of the airflow over various parts of an aircraft shifts between subsonic and supersonic. It is mostly seen in aircrafts. Okay, that's all for transonic. Let's move to supersonic. A supersonic missile exceeds the speed of sound, that is, Mach 1, but is not faster than Mach 5. Most supersonic missiles travel at a speed between Mach 2 and Mach 3. The most well-known supersonic missile is the Indian BrahMos, is currently the fastest operational supersonic missile in the world, capable of speeds around 2,100 to 2,300 miles per hour. Let's understand this in another way. A bullet fired from a gun is an example of an object that flies at supersonic speeds. A hypersonic missile exceeds Mach 5 and is 5 times faster than the speed of sound. Hypersonic missiles come in two variants: hypersonic cruise missiles and hypersonic glide vehicles. What is a hypersonic cruise missile? This type of missile reaches its target with the help of a high-speed jet engine that allows it to travel at extreme speeds, in excess of Mach 5. It is non-ballistic, the opposite of traditional intercontinental ballistic missiles. In short, ICBM, it utilizes gravitational forces to reach its target. What is a hypersonic glide vehicle? This type of hypersonic missile utilizes re-entry vehicles. Initially, the missile is launched into space on an arching trajectory, where the warheads are released and fall towards the atmosphere at hypersonic speeds. The warheads are attached to a glide vehicle which re-enters the atmosphere, and through its aerodynamic shape it can ride the shock waves generated by its own lift as it breaches the speed of sound, giving it enough speed to overcome existing missile defense systems. So the question arises, can hypersonic missiles be stopped? When hypersonic missiles become operational, the gap between missile defense systems and missile offense will be huge. Simply put, there is no operational missile defense system that is capable of intercepting a hypersonic missile, which is why the race to develop hypersonic weapons is such an important one. However, as defense technology progresses, countermeasures will emerge. Hypersonic missiles remain a closely guarded secret, but in recent months, many governments have announced successful tests and future projects.
What if an object exceeds Mach 10?
Well, there is more than hypersonic, and they are known as high-hypersonic and re-entry speeds. In high-hypersonic or hypervelocity, the Mach levels are between 10 to 25. When flying at such huge speeds, thermal controls becomes an integral portion of the design. The hotness of the surface must be considered beforehand. For example, NASA X-43 is one of the fastest aircraft, with Mach number reaching 9.6. In re-entry speeds, the Mach number is greater than 25. This does not require wings and a blunt design. Ablative heat shields are used, which lifts off the hot shock regions from the surface and protecting it from being damaged.